Hello everyone, welcome back. In our last lesson, we looked at the four rules of sort. We looked at the multiplication rules, the division rule, the addition rule, and we also looked at the subtraction rule. In today's lesson, we're going to look at basic forms of sort and similar sort. Now, if I have a number p, root p, okay, root p is a sort and p represents a number. Now take for instance, if I have roots, let me say roots 18. Okay, now let's check if root 18 is a basic sort or not. Of course, root 18 is a sort. Now we need to know whether it is a basic sort or it is not a basic sort. Now how will I know? I will break it down. Into two other numbers. Now 9 times 2 can give me this 18. So root 9 and root 2 will give me root 18 because 9 times 2 is going to give me 18. Now, because we have one of the numbers to be a perfect square, 9 is a perfect square. Since one of the numbers is a perfect square, so this very root 18 is not a basic sort. Remember, what are perfect square? Now, perfect square are numbers that can be expressed as a square of another number. Now, look at this 9. 9 is a perfect square because I can express it as a square of another number, that is 3 square. 3 square. Likewise, 4. 4 is also a perfect square because I can express it as a square of another number. In this case is 2. So if you have a sort like this 18, and when you break it down, one of the number is a perfect square, we will say that this very sort is not in its basic form. So this one is not a basic sort. Why is it not a basic sort? Because one of the numbers, after breaking it down, one of the number is a perfect square. So, of course, root 9 or square root of 9 is 3. That's 3 times 3, 9. This is times root 2. So this is also giving us to be equal to 3 root 2. So, but this very one now is in its basic form. This one is not in basic form because I have one of the numbers to be a perfect square. Now, let's check another example. If you have, let's say for instance, you have root 6. This is a sort. Now, root 6, we can break it down. We can still break it down. But is there any perfect square when we're breaking it down that can we get a perfect square as one of the numbers when we break it down into 2? I don't think so. But let's see. 2, I think, times 3 is giving us 6. So root 2, root 3 is giving us root 6. Root 2 times root 3 will give us root 6. Right? Now, if we check, none of this is a perfect square. 2 is not a perfect square. 3 is not a perfect square. So because of that, root 6 is a basic sort. This one now is a basic sort. Why is it a basic sort? Because after breaking it down into 2, none of the numbers is a perfect square. So we say that this root 6 is in a basic form or is a basic sort. Now let's still try another one. Let's try another number. like let's say 20. Okay, 20. Now, can we break 20 further? Yes, we can break 20 further. Now, 4 times 5 will give us 20. So root 4 times root 5 is going to give me root 20. Right? Remember that one of the rules we looked at is the same thing as root 4 times 5, which is equal to root 20. Hope should the same thing as root 20. Now, is this root 20, is it in its basic form? The answer is no. Root 20 cannot be in basic form. Why? Because after breaking it down, one of the number is actually a perfect square, which is 4. 4 is a perfect square because 2 times 2 is 4. So 4 is a perfect square. So because of that, root 20 is not going to be a basic surd. So if I break down this, square root of 4 is 2. So this is going to be equal to 2 times root 5. So root 20 is now going to be equal to 2 root 5. So I've broken it down, or rather I've simplified it to a basic surd. So this very one now we can say it is in a basic surd. This is a basic surd. Okay, I believe the concept of basic surd should be very clear. So just take note, if one of the number is a perfect square, then it is not a basic surd. All right. So what about let me say 15. 15, let's say root 15. Is it a bit? Let's check if this is a basic surd or not. Let's check if it's a basic surd or not. So this is giving us we can say 5 times 3 root 5 root 5 and root 3. Of course, none of these numbers here is um, a perfect square. So root 15 is a basic surd. So this is a basic surd. All right. So now, how do I identify similar surd? Now let's look at similar surd now. Similar surd. Now, surd are similar if the irrational parts contain the same number. Now look at this very surd. If you have surd like 6 root 2, okay, and let me see, let's compare with another surd. Let's say 4 root 2. Now let's compare these two surds, this surd here and this surd here. Now the irrational part is the root. This is the irrational part of this surd. Root 2 is the irrational part here, and here root 2 is the irrational part. Because they are the same, we will say that they are similar surd. Now because the irrational part root 2 is equal to root 2, we will say that these two surds, 6 root 2 and 4 root 2, are what? They are similar. They are similar surd. Yes, they're going to be similar surd because the irrational parts are the same. So what about a surd like this? Let me say 4 root 3 and let me say 5 let me say root 2. This one is not similar. These two surds are not similar surd. Why are they not similar surd? Because the irrational part, that's the root part of it, they are not the same. Now root 3 is not equal to root 2. Because of that, 4 root 3 and 5 root 3 are not similar surd. So this is not similar surd. I believe this is very clear. In our next lesson, we'll look at what conjugate surds are. Thank you for watching.